Algorithms and data structures are foundational concepts in computer science, essential for solving complex problems efficiently. Here's a detailed breakdown. Algorithms. Definition. An algorithm is a step-by-step procedure or set of rules for solving a particular problem or accomplishing a specific task. Characteristics. Correctness. An algorithm should produce the correct output for any given input. Efficiency. It should use the least amount of resources possible, time, memory, etc., to solve the problem. Finiteness. The algorithm must terminate after a finite number of steps. Input, output. It should have well-defined inputs and outputs. Types. Sorting algorithms. Arrange items in a particular order, e.g., quicksort, merge sort. Searching algorithms. Find an item in a collection of items, e.g., binary search. Graph algorithms. Manipulate data structured as graphs, e.g., Dijkstra's algorithm, depth-first search. Dynamic programming. Solve complex problems by breaking them down into simpler subproblems, e.g., Fibonacci sequence. Greedy algorithms. Make a series of choices that seem best at each step, e.g., Dijkstra's algorithm for shortest paths. Analysis. Time complexity. Measures the amount of time an algorithm takes to run as a function of the length of the input. Space complexity. Measures the amount of memory an algorithm uses as a function of the length of the input. Big O notation describes the upper bound of the time or space complexity in terms of the input size. Data structures. Definition. A data structure is a way of organizing and storing data so that it can be accessed and modified efficiently. Types. Arrays. A collection of elements stored at contiguous memory locations. Linked lists. A linear collection of elements where each element points to the next. Stacks. A last-in first-out (LIFO) data structure. Queues. A first-in first-out (FIFO) data structure. Trees. A hierarchical data structure with a root and subtrees. Graphs. A collection of nodes, vertices, and edges that connect pairs of nodes. Hash tables. A data structure that maps keys to values for efficient lookup. Operations. Traversal. Visiting each node exactly once. Search. Finding a particular element in the data structure. Insertion. Adding a new element to the data structure. Deletion. Removing an element from the data structure. Analysis. Time complexity. How the time required for various operations grows with the size of the data structure. Space complexity. How much additional memory is required to store the data structure. Relationship. Algorithms often rely on specific data structures to efficiently solve problems. For example, sorting algorithms often use arrays, and graph algorithms heavily depend on graph data structures. Understanding both algorithms and data structures is crucial for developing efficient software solutions.